Hi guys, I'm Carolina and I work with data. The very first thing I want to say is that I opened an account on Ko-fi. So if you enjoy watching my videos, if you found some of them interesting or funny or useful and you want to say thanks, now you can do it by getting me a cup of coffee. You can find the link in the description. I love coffee. Today I'd like to talk about the most important topic in machine learning at the moment. It is something that companies are just crazy about. Let me start with a story. As you may know, I am interested in stock market predictability, and because of that interest, I decided to do my computer science master's thesis about that topic. It was a huge project for me, and I was working with the world leading NLP researcher, cutting edge research. I was working on something that people were not even studying in the academia. It was amazing. So I was able to work with him and implement his cutting-edge NLP ideas to my research, to my data on the stock market. Without going too much into details, I was basically taking tweets and then extracting various structural information from that text using various feature extraction techniques such as BERT and FastText and some other ones. And then I was fusing those features, those various vectors, into one vector in a multi-dimensional vector space in a process called multi-view learning. That was giving me a very sort of well-rounded definition of those tweets, of that textual information, because it was as if I was looking at one piece of text from multiple perspectives. And then I could correlate those textual features expressed in numerical form with stock prices. And I was doing that using neural networks, decision trees, and a couple of other machine learning algorithms. And that was giving me pretty good results. So I could probably make billions with my trading strategy, right? But because I'm such an altruist somewhere deep down, I first decided to message someone from an asset management company and ask them what they think about my research and share my greatest ideas. So here's the interesting bit. What did I do? I messaged the head of data science at one of the most reputable asset management companies, and I asked him, hey, is this potentially interesting to you? And he replied to me. That was a shocker. And he said, let's meet up. I'm not gonna lie, that made me a little bit nervous because I was like, what if my research is just bullshit and I'm wasting this person's time? Regardless, 2 weeks later, I'm sitting in the client room on the top floor of their huge office, ready to discuss my master's thesis. And here they come, 2 men. I can see that one of them is holding a couple of handouts in his hand. I get even more nervous. I introduce myself. They introduce themselves. I talk about my research. They give me the handouts. Guess what was on the handouts? Any guesses? Any guesses? They printed for me an academic paper summarizing the current attempts at model explainability in machine learning. Because, they said, your algorithm might sound great and it might even give you great results. But if you can't explain how the algorithm does it, then it is essentially a black box algorithm. And having a black box algorithm is as good as not having an algorithm at all. Now, I don't know about other industries, but in finance, you are obviously dealing with quite a lot of money. You're dealing with billions on an everyday basis. You're responsible for dealing people's pensions. You don't want to end up without a pension when you're 70, although I guess we will all end up without pensions actually. Such is life. Let's print more money. So obviously there is no room for mistakes, and people that run money, investors, they must be held accountable for their decisions. But they cannot be held accountable if they can't even explain how they made the decision. I'm not saying that they don't understand the model itself, but they do not understand how the model arrived at the prediction. So one of the most important topics in machine learning is model explainability, trying to increase model transparency, trying to understand how the model makes the decisions, makes the predictions. But firstly, just to clarify this, what would be the most explainable model? Of course, that would be simple linear regression. And the reason for that is because you can easily relate your x's to your y's, and you can understand what is the meaning of, each coefficient, more or less. Whereas in neural networks, we don't know how the variables are combined to make the final prediction, how the model combines them. And there have been multiple attempts at increasing this model transparency, at increasing explainability. So let me summarize a couple of them for you. LIME, local, interpretable, model-agnostic explanations. It is a package, a library that you can use. I'm linking it in the description below. It explains the prediction of any classifier by learning an interpretable model locally around the prediction. And if you want to learn more details and understand the inner workings of that, I'm linking it in the description below, like I said. 2. SHAP, shapely additive explanations. This is an attempt at combining, unifying all the previous attempts at model explainability, such as LIME and some other ones, and making them all together a bit more robust, a bit more intuitive. Again, for technical implementations and details, I will refer you to a link in the description. Actually, you might be interested in going through this free SHAP tutorial released by Kaggle, which I'm linking in the description below. I think it will give you a bit more insight into what SHAP actually does. Turing bot software, a software that allows you to derive, to discover mathematical formulas in the data without making any prior assumptions on what those formulas might look like. This is also called symbolic regression. So basically you have a bunch of data and the software figures out by itself what the model should look like. Symbolic models are explicit, making them explainable. There is a free version of Turing bot software. You can use it for however long you want, as far as I know, and I'm linking it in the description below. There are academic papers published on this topic every month, so this video is going to get outdated pretty fast. So if there are any more recent methods that you heard of, if you are someone from the future, then let me know in the comments below. I mean, not like an alien or something, but let's say you're watching a year from when it was released, right? But what I've mentioned are some of the most interesting, some of the most prominent solutions at the moment. If you disagree, feel free. Maybe you have a better solution. Let me know. As always, I hope you enjoyed watching this video. I am linking plenty of stuff in the description below. And I guess I'm gonna get some coffee now. Wink, wink. See you guys.